Yes. Now let us see this question that came in NEET 2025 physics. This question is related to thermodynamics. Here it is an oxygen cylinder of 30 liter having 18.2 moles of oxygen and the temperature is 27 degrees C. But what you have to do, you have to withdraw some of the oxygen. That's what they have said, so that the gauge pressure, so we will come back to it. Gauge pressure drops to 11 atmospheric pressure. The gauge pressure drops to 11 atmospheric pressure at temperature 27 degrees C. Then mass of oxygen that you have to withdraw from the cylinder has to be calculated nearly, right? Nearly we have to calculate. So what approach we can follow? As you can see that there is the state of oxygen is going to change, right? But there is one more twist, that the number of moles you have to account for, what is before and after. So at least before is 18.2. So what do we have? N1 is equal to 18.2, right? N2 we don't know. What else we know? We know that the gauge pressure drops to 11 atmospheric pressure, right? So what is the gauge pressure? Let's say earlier the pressure was P1. So P1 minus P naught is called gauge pressure. This was the earlier pressure. Now let's say the final pressure is P2. So P2 minus P naught will be the gauge pressure after. So they say there is a drop in gauge pressure to 11 atmospheric pressure. So let us see what is the drop in the gauge pressure. So gauge pressure drop will be P1 minus P naught minus P2 minus P naught. This drop is 11 atm. That is what is given, right? So if you just clearly see, that means P1 minus P2 itself is 11 atm. Now what else we know? So from the first oxygen in the cylinder and what will be the final state of the cylinder, right? If you take out 18.2 moles of oxygen, right, what will be equal? So the temperature seems to be same, right? 28.7 degrees C. So keeping the temperature same, and also the volume of the cylinder will be same, right? So if you think of PV is equal to nRT before and after, what is going to change? The pressure and the number of moles are going to change. The volume is remaining same and temperature is remaining same, right? And R is anyway constant. So what equation you will have? You will have P1 by N1 must be equal to P2 by N2, right? Think of it. PV is equal to nRT. Everything else RT by V is a constant. So P by N will be constant. So this will be your kind of process equation, like, before and after. You are just comparing two states. Now, what do we have? What we have to calculate in this is what will be the mass of oxygen that is taken out. That is relevant to N2, right? So if you find out that, how much it is taken out, how much is remaining. So from remaining, you can find, this will be our map. First we will find what is N1 minus N2. This is what you have to find, the number of moles that has been taken out. Then this is the number of moles that you have taken out. If you find this, you multiply it by the molar mass. Number of moles taken out multiplied by the molar mass, answer will come in gram and all. Then you convert it into kg. So that's what it is asked, right? And that's why you can see there is a molar mass of oxygen given. Mostly we remember, but it is given, good, right? What else is given? The atmospheric pressure, right? Anyway, that is also relevant over here. Let's see how do we find out N1 minus N2. N1 we already know, we just have to find N2, right? We can find N2 in terms of N1. How we can do that? So let's go back and see the initial state of the gas. What they have given? The volume is given, mole is given, temperature is given, right? We can find pressure from there. So we'll get P1, right? P1 we will get. From P1 we will get P2 from here, this equation. Then we will put P1, P2 in this equation. We will get N2 in terms of N1. So that will be our plan. So let us see how do we get there, okay? So let's write PV equal to nRT. In the initial case, P1, let's say P1 is equal to multiplied by P1 we have to know. So multiplied by 30 liter. 30 liter will be like 30 into 10 to the power minus 3 meter cube, right? And then we will have N is given as 18.2 multiplied by R. Use the value of R that they have given over here for easier calculation. So it is like 100 by 12, let's say, and then multiplied by the temperature, absolute temperature. So 27 degrees C, around 300 Kelvin, right? So we'll get 300 Kelvin over here. If you calculate this, what are you going to get? So 30 and this 300 you can cancel. Then you can work out on this, 12 into 162, somewhere around 5, 12, 5, 60, right? And then you will just see the order. This 30 and this can cancel. 10 you have 1000 here, then 10 to the power minus 3 when it comes over here. Another 10 to the power 3 you have to do. So this will become 10 to the power 6. And this is our P1 approximately, which you can write in terms of atmospheric pressure. That will be great. So you take 110 here, you'll get 15 into 10 to the power 5. That much, right? So 15 into 10 to the power 5 can be written as 15 atm. No big deal, right? So now P1 is 15 atm. So if you write P1 equal to 15 atm over here, let's come back here, we'll get P2. So if P1 is 15 atm, P2, which is P1 minus 11 atm, will come as 4 atm. Now you come back here. If you know what is P1, what is P2, you can, and also you know N1, you can find N2, right? So let us find out what this value will be. Let's substitute from here that what is N2. N2 is N1 minus N2 is P2 by P1 multiplied by N1. Then whole thing should be multiplied by molar mass. Okay, and then converted into kg. Now what is P2 by P1? P2 by P1 is 4 by 15. Substitute it here. N1 is, you take out. Then we have 1 minus 4 by 15 multiplied by molar mass. Okay, then you multiplied it, convert, this will come in gram, you divide it by 1000, okay, 10 to the power minus 3, you will get in kg, right? Let's put the values. This is 18.2 multiplied by 11 by 15, right? 1 minus 4 by 5, then molar mass is 32. They have already given 32 gram. This is in gram. Then you multiply it with 10 to the power minus 3. If you solve this, you will get the answer. Okay. Thank you.